All right, let's talk about the 3.1 section here. So in 3.1, we are going to begin talking about parallel lines, and later on, perpendicular lines, okay? So parallel lines and perpendicular lines. So parallel lines, and you guys have probably heard that term before, but parallel lines do not intersect. They don't intersect and they're on the same plane as well. But, you know, if you just looked up towards the front of the classroom, you know, you could pick like this line up here, you know, this piece of corkboard and this line here. If they were extended forever, they would not intersect. Those lines are parallel, just like all the grout lines in the brick wall behind you. So those are parallel lines. Perpendicular lines, okay, perpendicular lines do intersect, but they intersect in a special way to form 90-degree angles. Okay, so they form a right angle, and that's really important. So that's why we talked about at the beginning of class that idea of complementary angles, because that leads into perpendicular lines. Okay, now parallel lines, they do not intersect, but they also need to be on the same plane. Or remember that term coplanar? So for example, if you used this caulk piece or cork piece as one line, and then you used, let's say, this line going up and down by the window as another line, if you extended them forever, those would never meet because they'd always be separated by this much. However, they're not considered parallel. Okay, so parallel lines never meet, but they have to be on the same plane. Okay, so like the corkboard and then, you know, this line here that holds the markers, those are on the same plane because they're all in the front of the classroom, so those are considered parallel. All right, so let's go down here a little bit. And so this figure here is three-dimensional. And so we need to visualize that a little bit. Lines that are parallel to AB. Okay, so AB is here. Let me make that a little thinner. So if AB is here, there are many lines that are parallel to that. I would say this line here, DC, okay, or we could say segment DC. But there's also EH and FG. Yes, very good. So we would say all three of those. We would say DC, and I will put the line above it because it asks for what lines. If we had line DC, line EH, and line FG, those were the three, right? All right, so all of those are parallel to AB. Now, again, though, notice like GH down here, the bottom right of that box, that never would intersect the top. It would not intersect AB, but that is not considered parallel. Okay, not considered parallel. So lines that are in the second part perpendicular, they have to cross but make a 90-degree angle. So if it's perpendicular to AB, it has to touch it. So something like CB and AD, those would be perpendicular. They make 90-degree angles or right angles. So we would say line AD.
What about AF and BG?
And line BC. Say that again?
What about AF and BG?
Yeah, good question. AF. Here, let me. More writing. AF is also considered perpendicular. You are totally correct. Because it does intersect and it does form a right angle. And you said, which other one?
BG.
BG, yes, very good. Those are also considered perpendicular. All right, you're getting it for sure. So we also have AF. We have BG. All right, great job. We're gonna skip the part where it talks about planes. We'll come back to that later, okay? So any questions on that so far? So parallel and perpendicular, we just need to visualize a little bit with those 3D objects. So let's go down here. And what I want you guys to do is take just a minute here, and would you guys please answer questions 1 and 2? Name lines that are parallel and lines that are perpendicular to BF. All right, so lines that are parallel to BF, there are 3 of them. I think 3 of them, right? We have DH would be considered parallel, so I would say line DH. AE and CG.
Wait, do we put arrows on it? It's, if there's no arrows on the line there, it's just, it doesn't have the continuation.
Yeah, great question. So, I noticed I put arrows on these when I notated it, because it asks for what lines are parallel to it. So when I say line DH, I'm considering if DH was extended forever as a line. And I did that because it asked for a line, so I put the arrows on it. Even though this DH does not have arrows on it, we're saying if it was extended forever, it still would not intersect that line. Okay? And so in a similar way, lines that are perpendicular to BF, now there's actually a bunch of them. If we're looking on the right side, we have EF and AB. So line EF and line AB. Looking on the back, we also have CB and GF. So line CB and line GF. Are we okay with those? Any questions? All right, so let's keep rolling then. If you look down here at the next picture, now this is about how do you show that things are parallel and perpendicular when it comes to sketching them. Well, here's how you show that lines are parallel. Okay, if they are parallel, you put these arrows on lines. Okay, if the arrows are not on lines, that means you cannot say for sure that they are parallel. But because line AC and line BD have arrows on them, we could say that that is a pair of parallel lines. So we would say AC and BD. Okay, and again, they have to have these arrows on them to show that they are parallel. So, all right, don't miss this up here, that if they are parallel, this little symbol right here, 2 lines kind of slanted by each other, that tells the reader, you would read that as AC is parallel to BD. Okay, that's what those 2 lines mean. That is the notation for parallel. And you can see it's right here in that part C. I'll get to that in a minute. All right, for the next part, name a pair of perpendicular lines. Well, if they're perpendicular, then we are looking for a right angle. So we could say that line AC is perpendicular to AB. AC and AB are perpendicular because they form a right angle there. Yes, we have a question. Yes. So we have line AC and line AB. Now I'm going to put a symbol in between there again. I'll show you that in just a second. Okay, so we have AC and AB. So again, look at this symbol. It's like an upside down T. Okay, that symbol means perpendicular. So those are two symbols that you'll come across as you're doing your homework, the parallel symbol and the perpendicular symbol. All right, so the next question for, let's see, is ED, this guy, parallel to AC? Are those two parallel? No, right? They would, why are they not parallel? Well, because they would intersect down here somewhere if we extended them. So is EC parallel to AC? No, because they would intersect. Okay, so no, those two lines are not parallel because they would intersect. All right, any other questions before I move on to the last section? All right, looking in your notes here. Actually, let's have you do this. How about if you guys do these questions 5, 6, 7, and 8? Take a couple minutes, name those parallel and perpendicular lines. Then we'll go over those in a minute, and then I have just one more small section to show you. Okay, so do those 5, 6, 7, and 8. Okay, to name a pair of parallel lines, I did see many of you had these correct, but be very careful of your notation. If they're parallel, of course, we're looking for those arrows that are kind of in the middle of the lines to show that AB is parallel to CD. Okay, so we would say that line AB is parallel to line CD. And notice that I put that symbol in there. Okay, some of you guys were missing that symbol. Yes. Yes. So like in the next one, because they're perpendicular, we'll put that perpendicular symbol. So name a pair of perpendicular lines. I'm looking for the right angle here. And so AC is perpendicular to CD. So we would say line AC is perpendicular to line CD. Okay, and make sure you have that perpendicular symbol so that you're telling the reader if those two lines are perpendicular. All right, so is AB parallel to BC? So is AB, which is this guy, parallel to this guy? No, because they intersect. So no, because they intersect. And the next question is BD perpendicular to CD? Is BD perpendicular to CD? The answer actually is no. I know a lot of you had said yes, and I agree with you. It looks like they are. It definitely looks like they are. However, there is no right angle symbol mark there. We don't have any degree measures, so we can't say for certain that they are perpendicular. And so we could say, is it perpendicular? No. They are not marked perpendicular.
So pretty much we have no proof.
Exactly. So like, I don't know, does it look like they are? Yeah, I agree with you. They look that way, but we don't have any proof. All right, well, the next part is going to be more about finding numbers, finding actual angle numbers. And I'm going to draw a picture. So before I do so, are there any questions on these? All right, I'm going to use this empty space here. And I'm just going to draw a line or a segment and another one that intersects it, okay? And in doing so, I have an obtuse angle and acute angle, and I'm gonna make up a number here. I'm gonna say this is 50 degrees. Okay, so I have two lines that intersect. I have the acute angle is 50 degrees. Now, if you remember what we talked about before with linear pairs and vertical angles, we should be able to find all of those other three measures just by giving one. As soon as you know one measure, we should be able to find the other three. Because remember, the vertical angles, the one that are across from each other, those are the same measures. So that will be 50 degrees also. Okay, because the vertical angles are congruent. They have the same measure. And the angle supplementary to 50, well, remember, those two have to add up to 180. So that means that this angle must be 130 degrees, because 130 plus 50 is 180. And so if that's 130, its vertical angle is also 130. Okay, because the verticals would be congruent, or these two have to add up to 180. So all the numbers should work out. Are we okay with that so far? Because now I'm gonna change this picture. So any questions on that? All right, so just take a look up here on the overhead. What if I took this and I copy it and paste that right there? So I have this angle right here, and I'm gonna slide it up to form a picture like this. So like these four angles corresponded to all of these angles up here. Okay, again, I'll show you, where I got that from. If I took this, if I took these angles and I just slide them up, all of these angles correspond to all of their guys down here. The reason I'm saying that is because now these lines are parallel. So remember, this is our parallel notation. So if you have that parallel notation, and I started this whole picture with just this 50 degrees, I was able to find 8 angles, or 7 others, I guess, just by giving that one angle. Okay, so if I knew that one angle, I could find all of those other angles. So let me give you a similar one, and you guys don't even need to write this down. Let's say we had, 2 other parallel lines. And I will draw arrows on them to indicate to the reader that they are parallel. And let's say I had another line that cut them. Okay, so we call it a transversal. I'll talk more about that. This angle right here, is it acute or obtuse? Definitely obtuse, right? So I'm going to make up a number. I don't know, let's say that is 110 degrees. If we know that angle is 110, I should be able to find that one, and that one, and that one, which then would allow me to find all 4 of these guys. So I should be able to find all of those other angles just by giving that one. And remember, that only works if the lines are parallel. So with that 110 degrees, I know its vertical is 110. I know that this angle has to be 70, because remember, they have to add up to 180, right? 110 plus 70 is 180. And so I know that that guy is also 70. And so now I have this big pair of angles. And so now, oops, I'll go right there. Okay, so once I know that one angle, I then can find all of those others. All right, any questions on that?